Hello there, myself Ashok Sangre. As you know, this is our seminar work as a part of coursework. My topic is geospatial based site evaluation and potential assessment of urban rooftop for planning of agrivoltaics. In this topic, I would like to evaluate the whole site of this one particular city. If we consider, for example, Aurangabad, this is urban area, and this area, how a lot of area in this city, how we use that particular area for the purpose of agrivoltaics. So how we can do and how we can measure that area and which area. So the concern this city, the area is uh, already used for a lot of areas, built up area, and other area is a road purpose, and for some other built up structures are there. So for within that, if you want to plant, if you want to make more greenery, where which area we utilize for that concern. So to make a planning in a geospatial environment and find out the area and use that area appropriately for agrivoltaics. Agrivoltaics means it is a word made up from two terms. One is agriculture and another one is photovoltaics. So this, let's see. Uh, so agrivoltaics means in that farming crops under the shade of solar energy, solar photovoltaic systems. In this picture, you see there is a solar panels, and inside the panels there is a some different greenery, and how we can utilize that. And so for that, we need to find out the space which is openly available. So lot of space is there, but we not find out that and utilize. So to find out as this rooftop space, in order to that, we need to find out all the buildings. We need to find out we need to identify all the buildings of these urban cities. And once we find out the building, so each building have its rooftop area. So once we find out that, then we know that the area in square kilometer, and if this much is area there, so for that area how much solar panels is required, and inside the solar panel we again utilize that space for greenery purpose. So to measure as such a potential, so for that we use some remote sensing images and GIS tools. So because of growing population, urbanization, and industrialization. So because of that, the lot of stress over on existing resources. Their resources, maybe if we consider electricity, power. So if because of the industrialization and urbanization or population, it will require more and more. So to overcome this, so we need to utilize access resources properly, and for that, this research is exploring this type of ways. So if there is a concern with recent population and pollution or environment or surrounding, there is no as such healthy surrounding in urban. So if there is more greenery, the surrounding ultimately get healthy. So if we not plan these agrivoltaics, and if we plan, so there are these graph indicate that without planning, if we this red line indicate that the uh, the trace or load uh, there if we not plan agrivoltaics. So if we plan agrivoltaics, then stress gets reduced. If we use existing that rooftop areas and we plan, we measure the potential, how much area is there and how much we able to do that agrivoltaics there, or we utilize that area properly, then we utilize resources over the population or industrializations. So ultimately, by value, okay, it is a 78, and without analysis, it may be 81. As this graph give a sense, for that I utilize this graph. So what is actually behind my idea? You know that. So there remote sensing images are there. So we need to get proper images. From that we classify that image and identify the buildings. Once we identify the buildings, so building roof surface and road surfaces, how we classify that and discriminate that. So we can, for that we have a GIS, geographical information system, and from this tool we construct the features and we find out the features. So then we appropriately predict the group of surfaces, and we represent that surface like in a 3D form. And once we represent that in 3D form, then we need to extract the polygon of each building's rooftop. And once we find out that polygon, After that, we represent that area. Let's see this graph. This graph indicate that the area in square kilometer and the number of buildings is 1,115. So for pilot project, I do this study and find out this number of buildings, and for this building, this much area is available. So if we plan uh, our targeted outcome is that building and area, and once we know that area, then for such practices, there is a lot of available space, or we if we do as such, there is a more benefit from that. So it will provide architectural enhancement, it will improve the air quality, reduce city heat effect, reduce noise and pollution. So again, provide habitat for wildlife benefits, while there is a butterfly and there. So it will change the environment also, city's environment also, from pollution to likewise a healthy or quality air quality is there, or healthy environment is there. So again, so uh, for that, I need to quantify building the area, area, and establishing. So in this way, I establishing a benchmark for agrivoltaics. So ultimately, this research work for transforming a database into agrivoltaic space purpose. So in this way, this study have a lot of benefits. So it's a smart solution for a smart city, better use of sunlight heating rooftop surfaces. Thank you. Thank you very much.